वेलकम इन अनदर वीडियो ऑफ इंटरनेट ऑफ थिंग्स। स्टूडेंट, लास्ट लेक्चर में हमने चैप्टर नंबर 4 विच इज़ द पार्ट ऑफ यूनिट सेकंड दैट इज़ थिंकिंग अबाउट प्रोटोटाइपिंग कंप्लीट किया था। तो आज की इस वीडियो में हम चैप्टर नंबर 5 दैट इज़ प्रोटोटाइपिंग एम्बेडेड डिवाइसेस, जो कि यूनिट नंबर सेकंड का बी पार्ट है, वो स्टार्ट करेंगे। ठीक है, तो शुरू करते हैं आज का वीडियो। तो चैप्टर नंबर 5 जो कि है प्रोटोटाइपिंग एम्बेडेड डिवाइसेस। ठीक है, तो उसमें हमने सबसे पहले लेना इलेक्ट्रॉनिक्स। ठीक है, व्हाट इज बाय इलेक्ट्रॉनिक्स? सो इन दैट फर्स्ट पॉइंट इज मोस्ट ऑफ द प्रोटोटाइपिंग कैन बी डन ऑन व्हाट आर कॉल्ड एज अ सोल्डरलेस ब्रेड बोर्ड्स। ठीक है, सो द ब्रेड बोर्ड इज यूज फॉर टेम्पररी कनेक्शन ऑफ इलेक्ट्रॉनिक कंपोनेंट्स। तो जो भी प्रोटोटाइप आप बनाओगे, ओके, फॉर योर IoT project, so that prototype needs the temporary connection of different sensors, actuator and the components. So these components can be connected on the breadboard for a temporary purpose. Means simply a electronic circuit can be made on this breadboard. Second point, they enable you to build the components together into a circuit with just a push fit connection. ठीक है, तो ये टेम्पररी पर्पज़ के लिए जो इलेक्ट्रॉनिक कंपोनेंट्स का कनेक्शन होगा वो हम ब्रेडबोर्ड पे कर सकते हैं। सो दैट बिल्ड्स द कंपोनेंट टुगेदर इनटू अ सर्किट, सो इट मेक्स अ सर्किट ऑन द दिस ब्रेडबोर्ड्स. Third, when it comes to think about electronics, it's useful to split them into the two main categories. So the electronic components are specially divided into the first one, sensors, and second one is the actuators. So sensors, these sensors and actuators are generally used as a electronic component in your IoT projects. So first we'll see the what is by sensor. So sensor are the ways of getting information into your device and finding out the things about your surrounding. ठीक है, तो सेंसर का काम इस तरह से कि वो जो भी इंफॉर्मेशन रहेगा, ठीक है, उसको वो सेंस करेगा and that information is converted into the suitable form and it give this input to the controller. So in simple way, the sensor will sense the surroundings and getting the information from the surrounding, and that is converted into the suitable form. So that is the simply working of this sensor. So there are different sensors are available, like temperature sensor, pressure sensors are there. So different sensors are available. Second one is the actuator. So the actuator are the outputs for the device, the motors, lights and so on, which let your devices to do something to the outside world. ठीक है, तो एक्चुएटर का काम क्या है कि सेंसर से जो भी डेटा रिसीव होगा माइक्रो कंट्रोलर में, ठीक है, सो माइक्रो कंट्रोलर will process that information and gives the output. That output goes to the actuator and the actuator will perform the action which is given by the microcontroller. So simply the motors or lights can be on or off, so that is the function of actuator. So simply actuator will perform the outputs. So the actuator is basically output device. So that is a simple function of this actuator, and these sensors and actuators are the main electronics components in the IoT project. Next point is, within both categories the electronics component can talk to the computer in number of ways. So these both sensors and actuator are the electronics components and they can communicate with the computer in the number of ways. Means this sensor and actuator will send the data to the computer and computer will process that data. The simplest is through digital input output, which has only two stages. Button can either be pressed or not, or LED can be on or off. So this IO means input output. So in digital form it has only two states, means simple LED will be on, means in digital it will be a 1, means high level, so that it can be on, or when it will be off means it will be a logically 0 or low level. So it has only two states, that is 1 or 0. So when button will be pressed the LED will be on, means it will be a logic 1, and when button will be closed, so it will be a switch off, means it will be a logic 0. Next point, these states are usually connected via general purpose input output, so that is called as a GPIO pins, and map a digital 0 in the processor to 0 volt in the circuit and digital 1 to set a voltage. So these sensors and actuators are generally connected to a Raspberry Pi. Okay. Then it is through a simply a PCB, so it has the GPIO pinouts, that is general purpose inputs and output. So we can assign this GPIO as a input or as well as output, so that will depend on the programming. So when this digital 0 in the processor, it gives the 0 volt, and in case of digital 1 it will be a set a voltage. ठीक है, जैसे हमने LED में देखा यहाँ पे ऑन एंड ऑफ. So we can assign these GPIO pins for the various purpose, or various sensors and actuators we can connect it through the GPIO pinouts. Next point, usually the voltage that the processor is using to run is commonly 5 to 3.3 volt. So the processor which are used in the IoT projects that needs the or its voltage requirement is in between 3.3 volt to the 5 volt. So that is the voltage requirement for the processor which are used in the IoT projects. Next one, if you want to more connection than just on off, you need an analog signal. Suppose you have to only a on off connection, so at that time you need analog signal. Next point, if you want to run a motor at a speed other than off or full speed, you need to feed it with the voltage somewhere between 0 volt and its maximum rating. Suppose you have a project in that a motor will be used, so that motor can be a on and off, or it can be run at a low and full speed. So at that time you need to feed a voltage somewhere in between 0 to the maximum rating. Okay, तो उसमें हमें वेरिएबल्स वोल्टेज यहाँ पे प्रोवाइड करना पड़ेगा, सो दैट मोटर स्पीड विल बी वेरी फ्रॉम 0 to the maximum value, just like a fan. Okay, so that is the point. Next point, because computers are purely digital devices, you need a way to translate between analog voltage in the real world and the digital of the computer. Okay, so we have to convert this analog voltage into the digital one, because the computer will only understand the digital, or it can process only the digital signals in the form of ones and zeros. So that's why we have to convert this analog signal or analog voltage into the digital form. So for that purpose we use the analog to digital converter, which is known as a ADC. So that will measure this varying voltage, just like this motor speed can be vary from low to high. So at that time the variable voltage will be applied to the motor, and this variable voltage can be converted into the digital by using this analog to digital converter. Next point is, microcontroller often have a number of these converters built in. So the microcontroller will consist of this ADC, which will convert analog to digital, and DAC, that is DAC, digital to analog converter, which are inbuilt in these microcontrollers. Next point, they will convert the voltage level between 0 and a predefined maximum into a number depending on the accuracy of this analog to digital converter, that is ADC. So these voltage levels, that is analog voltage level of 0 volt to the maximum number which is predefined. So this ADC will convert this analog voltage into the number, so that will depend on the accuracy of this ADC. Next one, the flip side of ADC is a DAC, so that is digital to analog converter. Okay, that will convert digital signals into the analog one. So DAC let you generate a varying voltage from digital value. Means it is opposite to the ADC. This DAC will convert the ones and zeros signal into the voltage level that can be vary from 0 to maximum values. So these are the some points regarding the electronics. Then we'll see the sensors. What is meant by sensors in the IoT? As the sensor plays an important role in the IoT projects, so push buttons and switches, which are probably the simplest sensors, allow some user input. So push button type and the switches form of sensors are probably the simplest form of sensor, which are used as a user input, and they will sense the environmental data and generate the output which is given to the microcontroller. So सेकंड पॉइंट, सेंसिंग द एनवायरनमेंट डेटा इज़ अनदर इजी ऑप्शन. ठीक है, तो सेंसर का काम यही कि जो एनवायरनमेंट का जो डेटा है, सराउंडिंग का जो डेटा है, वो उसे सेंस करके उसे एक सूटेबल फॉर्म में कन्वर्ट करेगा, लाइक अ टेम्परेचर सेंसर. सो टेम्परेचर सेंसर क्या करेगा, जो एनवायरमेंटल टेम्परेचर उसे सेंस करके उसे एक वोल्टेज फॉर्म में कन्वर्ट करेगा, एंड दैट वोल्टेज विल बी गिवन टू द माइक्रोकंट्रोलर फॉर द प्रोसेसिंग. नेक्स्ट इज light dependent resistor LDR that allows the measurement of ambient light levels. Temperature sensors allow you to know how warm it is, and the sensors to measure the humidity or moisture level are easy to build. So these are the different sensors. So this LDR is generally used to measure the light intensity levels. ठीक है, तो लाइट की जो इंटेंसिटी वो मेज़र करने के लिए यूज़ होता है लाइट डिपेंडेंट रजिस्टर. ठीक है, देन टेम्परेचर सेंसर विल सेंस द एनवायरमेंटल टेम्परेचर, लाइक दैट ह्यूमिडिटी सेंसर विल मेजर द ह्यूमिडिटी इन द परसेंटेज, और सेम लाइक अ मॉइस्चर इन द एनवायरमेंट, एंड दैट विल जनरेट द appropriate information, and it will given as a input to the microcontroller. Next is microphones. Obviously let you monitor the sounds and audio. So the microphones is also one of the example of this sensor. Microphones will convert the sound or sound vibrations into the suitable voltage, and that voltage is given to the amplifier for amplification purpose. So that's why microphone is also one of the sensor. Next point, distance sensing modules, which work by bouncing either an infrared or ultrasonic signals of objects, are readily अवेलेबल. ठीक है, सो इसमें डिस्टेंस सेंसिंग मॉड्यूल्स भी यूज़ होते हैं, दैट कैन बी यूज इंफ्रारेड और अल्ट्रासोनिक सिग्नल्स, एंड दैट कैन कन्वर्ट द सिग्नल इनटू द appropriate form, and it is given to the microcontroller. So these are the some points regarding the sensor, which is the one of the important component in the electronics. Then second component will be the actuator. So the first point in the actuator is one of the simplest and yet most useful actuator is a light, because it is easy to create electronically and gives an obvious output. So we know the actuator is the output devices, means microcontroller will process the data which is from given from the sensors, and that output data is given to the actuator, and the actuator will perform the appropriate action, which is the output. So these LEDs are typically comes in the red and green, but also white and other colors. So the LED is the output device, that is light emitting diodes, so which are available in the different color. It can be a red, green and white, and other colors are also available in the LED. So more complicated visual outputs are available, such LCD screen to display the text and even simple graphics. So just like that LED, LCD screens are also available that can display the output text or videos. Even a simple graphics can be seen on this LCD display, just like a LED display. So these LCD, LED are the examples of actuator, because these are the output devices. Next example of this actuator is you can wire up the outputs to the speaker to create more complicated synthesis sounds. Means the speaker is also example of actuator because the sound output comes from the this speaker. So it is in complicated synthesis sound like bass or terrible effects can be here by using these speakers. So the speaker is also one of the examples of actuator. Next, more complicated again are the motors. So motors are also rotate in clockwise and in anti-clockwise direction. So the motor is also example of actuator. So the example is stepper motor. Then can be a move into the steps as its name implies. So stepper motor is also one of the type of motor. So in stepper motor, the rotator will rotate in specific angles like a steps like 0, 30 degree, 45 degree, 90 degree, like that the shaft of the motor will be rotate in the specific angle. That's why its name is stepper motor, means it moves into the steps. Next point, usually a fixed number of steps is performed a full rotation. So DC motor simply move at a given speed when टोल्ड टू. ठीक है, तो जिस तरह से हमने एग्जांपल देखा कि स्टेपर मोटर विल रन एट द फुल स्पीड और फुल रोटेशन ऑल्सो, और इट कैन बी रोटेट इनटू द स्पेसिफिक एंगल और इन स्पेसिफिक स्टेप्स. So both types of motor can be one directional or move in the both the direction. So the simple motor can be run into the both the direction, means its rotor will be rotate in clockwise direction or in anti-clockwise direction also. So that will depends on the requirement of the projects. So these are the some important points regarding the actuator, which is the second most important component in the electronics. नेक्स्ट पॉइंट इज स्केलिंग अप द इलेक्ट्रॉनिक्स. जिस तरह से हम एक प्रोटोटाइप फर्स्ट बनाएंगे बाय यूजिंग द simply a breadboard. On that we are making the different components are connected, like these are the resistor, these are the diodes and the sensor, then actuators. That temporary connection is made on the breadboard. So from the perspective of the electronics, the starting point of prototyping is usually a breadboard. ठीक है, तो कोई भी प्रोटोटाइप अगर हम इंटरनेट ऑफ टेक्नोलॉजी से बनाएंगे, सो द स्टार्टिंग पॉइंट or prototype is start from the breadboard. So on that breadboard we connect the different components as per our project requirement. So that is the temporary connection of these electronics component, and that can be connected through these jumper wires. Means the temporary connection between these resistor diodes can be made through these jumping wires. So it's common to solder the components onto some photoboard, which may be sufficient to make the circuit more permanent. So instead of using this breadboard, we can also use the zero PCBs. On that we have to solder this component by using soldering. So that can be also do in prototyping. Next point, moving beyond the protoboard, that is also called as a strip board option, tends to involve the learning how to lay out a PCB. So we have to design the PCB, that is printed circuit board. So that consists of the copper conductors or copper strips are there on the PCB for the connection of the different components. So it involves the learning how to use the new piece of software and understanding some new terminology. So the photos are shown of a breadboard. So it consists of the different components, and there is a connection between these components. So there is a resistor, then diode, then transistor is used here, then LED display is used. So the component connection is made by using these jumper wires. So that is a temporary connection of this electronic circuit on the breadboard. So that is the first method for the prototyping. And and if the prototype will be successful on the breadboard, then we'll make the PCB for that circuit. So that consists of the connection between different components by using the this soldering. So that is the microcontroller use, and these resistors, these transistors are connected by using the soldering techniques on the PCB. So these are the some point discuss about the scaling of the electronics. Then next topic is embedded computing basics. So in that first we'll see the microcontroller. So microcontroller is the main brain in the this IoT technology and in IoT projects. So first point in that is this system combine the processor, RAM and the storage into a single chip. Means the microcontroller consists of the processor. So microcontroller is nothing but a controller. So it consists of RAM, which is in inbuilt. Also it has a storage, means registers are inbuilt in the microcontroller. These are different register, temporary register, then program registers are there, which are also in a single chip. Means microcontroller has combination of processor as well as RAM, ROM and a different temporary register for the storage, which means they are much more specialized, smaller than the PC equivalents, and also easier to build into the custom design. So these microcontrollers are smaller than their PC equivalents and also easy to build into the custom design. Means we can increase its storage capacity also by interfacing the RAMs and ROMs externally. Second point, microcontrollers are very limited in their capabilities. Means microcontroller will perform only a single task. So it will be a work in a real-time scenario. So usually they offer a RAM capabilities measured in kilobytes and storage in 10 kilobytes. So the capacity of RAM, that is random access memory, in microcontroller, which is in KB. So the size of the RAM will be in the KB, that is kilobytes, and the storage is near about 10 kilobytes. So that is the generalized criteria regarding the RAM and storage in the microcontroller. So there are different microcontroller families are available, like 8051, that is the most popular microcontroller. So the different family has a different features available, like the RAM capacity and in storage capacity is different for the different microcontrollers. Next point, the modern chips are much smaller, require less power and run about 5 times faster than the 1980s counterparts. तो 1980s में जो microcontrollers develop हुए थे, so as compared to that, the today's microcontroller is much smaller due to the enhancement in the VLSI technology, and that requires the less power. So the power requirement is also less in today's microcontroller, and that runs about 5 times faster than the 1980s microcontroller. So that is the today's advancement in the microcontrollers. Next point, the microcontroller market consists of manufacturers, each with the range of chips for different applications. So there are variety of microcontrollers are available in the market, or the chips are available that are used for the different applications. So we can choose the these different microcontroller chips that will depend on the requirement of our projects, like the RAM capacity, the storage capacity and the power requirement. So these are the different criteria for selecting this microcontroller. So the different vendors are available, or different companies will provide the microcontroller, like Atmel. This 8051 is made of this Atmel microchip, NXP, Texas Instrument, it is in short, that is TI, Texas Instrument. So these are the some of the companies that will manufacture these microcontrollers. The devices using them are focused on performing one task. तो जैसे हमने डिस्कस किया कि माइक्रोकंट्रोलर्स आर जनरली यूज टू परफॉर्म ओनली अ सिंगल टास्क, मीन्स वो एक ही टास्क के लिए काम करेगा. एज कम्पेयर टू दैट, द माइक्रो प्रोसेसर आर यूज फॉर द वैरायटी ऑफ work or variety of tasks, means that is called as a multiprocessing. But this microcontroller will be only perform the only specific task. So these are the some points regarding the embedded computing basis. So in that, microcontroller is the main brain of the system. तो आज का ये वीडियो लेक्चर हम यही एंड करते हैं. नेक्स्ट वीडियो लेक्चर में हम सिस्टम ऑन चिप का डिटेल स्टडी करेंगे. सो थैंक यू.